So welcome to this River Publishers book discussion. I'm Philippa Jefferies. I have with me Chi-Hao Cheng, professor at the Department of Electrical and Computer Engineering at Miami University. He has research experience in digital signal processing and optical communications. And today we're going to talk about his new book, An Introduction to Electronic Warfare, from the first jamming to machine learning techniques. Welcome. Thank you so much for joining me today.
Yeah, my pleasure. Thank you, Philippa.
Great. So to start with, the book looks at electronic warfare. But can you start by talking a little bit about what that term really means, what it encompasses, and kind of how it's developed?
Okay, so electronic warfare started with the development of radar. So radar was developed in the early age of World War II and was used to detect, of course, the object in distance and also used for fire control. After World War II, people began to use radar to guide missiles. And then the electronic warfare system then was developed to detect and take countermeasure to against radar, to disturb radar's operation. So using strong noise to disturb radar is an obvious solution, but then the radar operator will know it's being jammed. So the ideal case will be sending the wrong information or deceive the radar operator so that radar will lose the track of its target, but without knowing that. So on the other side, so radar engineer then will develop the countermeasure to against the countermeasure taken by electronic warfare system. Then of course, then the electronic warfare system engineer will respond, and that's what we call a circle of electronic warfare, which never end. And then somebody will try to break the circle. So since the electronic warfare system is to develop to disturb radar's operation, so the other way to think is if we can build an aircraft which cannot be seen by radar, then all of the trouble following will be avoided. So that's how people develop the stealth aircraft. So in theory, a pilot to fly a stealth jet fighter will be very safe because it's invisible to radar. So therefore, no missile can hurt that jet fighter. And so along the other way of thinking, so if the electronic warfare receiver is designed to intercept radar signal, if people can develop a radar which cannot be detected or difficult to be detected, then the radar does not have to worry about the countermeasures and it needs to take to against electronic warfare system. So that is why people develop we call a low probability of intercept radar. And so in this book, we try to cover the broad range of electronic warfare, but that is the basic introduction for this subject.
Okay, fantastic. And you talk about how it's not just like attacking, it's also defensive, trying to hide your planes that you talked about. What are kind of the greatest challenges at the moment within that and that kind of area of electronic warfare?
Yes, one major challenge in the electronic warfare receiver engineer or electronic warfare system designer facing now is the very congested radio spectrum. Compared with the early stage of the electronic warfare, say Vietnam War, now our radio spectrum is much more crowded, and we have the cell phone network everywhere. And so if the Elon Musk, his Starlink succeed, then it will have the global coverage. So we have a very crowded spectrum and so many signals there. And the electronic warfare system needs to identify the hostile radar signal. Out of all of those signals, you need to detect which signal is harmful and identify the radar and take countermeasure to against the radar. So that becomes a more difficult job than ever. And also due to a rapid progress of the affordable digital device and the software-defined radio, now it's much easier to develop a radar with a very complicated scan pattern and complicated signal. and worse yet, and the radar designer can reprogram the radar very quickly, very easy. So that make all of those tasks, that make electronic warfare system designer has a very tough game to play. So that is the major challenge in, I think, the modern electronic warfare system is.
And what are some of the ways you can kind of counter that? Because I guess it's kind of cat and mouse game that one gets better and the other has to catch up, and then the other gets better and the other has to catch up.
Oh yeah, it's always the case. It's
Yeah.
always the case. And I think, you can say to some degree the ground level, because those advanced techniques is available to both radar and electronic warfare receiver engineer. But I think right now it's maybe this little bit disadvantage for the electronic warfare people, because the radar people know what signal they are looking for. On the other hand, the radar electronic warfare receiver does not really know the signal it's looking for, and now it's hidden behind all of those clouded signals from other device, which does not present any threat. But on the other hand, then it just makes the signal finding job more difficult. But on the other hand, the other things like software-defined radio and affordable technology, digital systems, that is free for everyone to use. So electronic warfare receiver people also have an advantage of using advanced technology to develop their method, to develop their system.
Okay, and talking about kind of the development of technology, so one of the last chapters in the book looks at the use of machine learning within electronic warfare. I was just wondering if you could talk a bit about how machine learning is used for this kind of application and what the specific challenges are here.
Oh, yeah. If I can have Nico every time for people say machine learning. So nowadays, I think machine learning is everywhere. So if we check the history of technology, we will find out for some applications, like for some technology like aircraft or radio, and they will be applied for military application almost one invention. And machine learning kind of follow that track. And so you can imagine many people try to use machine learning for the military applications. And not every machine learning expert is happy about that. And they probably against this application, but probably nobody can forbid the military or around the world from using machine learning. But go back to electronic warfare, and I think from the open literatures, we can find out people has been using the machine learning to classify radar signal, to check if radar has been jammed, and to determine what's the radar's operational mode. And some people also try to use machine learning to advise the pilot which action to take during the real battle environment. And so there are so many, and we can be certain there are so many research ongoing about using the machine learning for radar or for electronic warfare. But there are still a couple of differences between the electronic warfare and the application, and which machine learning has been very successful applied to. The first thing is usually machine learning requires a lot of data for training. But you can imagine your enemy probably want to keep their equipment more secret. So to use machine learning to develop electronic warfare, and one challenge can be the lack of the data for training purpose. And that can be one challenge. And the other challenging will be like, unlike the game like chess or Go, which machine is way much better than human now. And for electronic warfare, so for those game, a strategic game, the rule is very clear defined, and there's no hidden information. So every information is front of the machine. But for electronic warfare, and we might not have every information, and or the enemy can also provide false information.
Oh, sure.
And for examples, when pilot going to on an action, it's part so the defender might have a new radar deployed, but we know nothing about. So that can be difficult, and there are so many uncertainties, and in the real world. But still, after saying that, yeah, we can be one thing can be certain is there are many people working on this field, and there will be many more people try to use machine learning to either improve radar or electronic warfare systems. And I think the duel between the radar people and electronic warfare people will never end, as described in our book.
Okay, interesting. I'm afraid we're coming sort of to the end of our time, but I guess we can't do this interview without mentioning your co-author, James Tsui, who passed away a couple of years ago. Could you please talk a bit about him and his influence in the book?
Okay, so Dr. Tsui is a very important figure in the field of electronic warfare, not just publishing many books, and he also pioneered in many of the electronic warfare technologies. He is one of pioneer in the digital electronic warfare receiver. He also developed, or at least he's one of the early developer of the instantaneous frequency measurement receiver. So a long time ago, when he was still with Air Force, and one of the book editor mentioned to him that, saying, "Hey James, there are so many interesting stories in the field of radar electronic warfare, and it can be a good subject for a book." So he was thinking about that, but at that time he focused on research and writing the book for professional. So he was thinking about that, but never take any action. Then afterwards, so I worked with him and on research project in his later day with Air Force, and we work very well together, and I learned a lot from him. And after he fully retired from Air Force, so he invited me to update his book, The Digital Techniques for Wideband Receiver. So we work on a book, we finished the third edition of the book. So after the book published, he brought this idea to me saying, well, this can be an interesting topic for us to work on. And I was very excited about this idea because I like history a lot myself.
Yeah.
So we began to do some market survey, so to speak. And what we found out is they are made some books about the history of electronic warfare and radar development, but they are not necessarily written by technical people or people working in this field. And of course, there are some books about introducing the electronic warfare technology, techniques, or radar, but usually those books do not talk about history. So then we plan to write a book to introduce the fundamental electronic warfare and radar techniques, and with some historic events, and some will come from Dr. Tsui's personal experience.
Yeah.
So we wrote several chapters, but when we contacted the publishers, and the feedback we receive is they want us to write another textbook for the professional, for engineer. So we began to thinking about which book we can write. But unfortunately, Dr. Tsui's his health deteriorated and passed away. And so in his funeral, and I promised to his wife, I'm going to finish this book, and since that's as a memorial to Dr. Tsui. And then Miss Nikki Dennis kindly suggests us to publish this book with reverse publisher. So I work on this book, and compared with our original outline, I added more technical content and more recent development like machine learning and the probability intercept of radar. And we are adding more recent development. But our original plan was to make sure that this book is accessible to the people who might not have a very extensive training in technology. And so I stick to this plan.
Yeah.
So I try to make this book as readable as possible for everyone. And so hopefully the reader will find this book as an interesting read. And after all, and to see how people on the radar side and on electronic warfare side and try their best to develop technology to outsmart each others. It's a very interesting story to read. But so it has been a little bit more than 2 years since Dr. Tsui passed away. And I'm just very glad finally this book is out.
Yes, it's fantastic. And I love how in the book there's also a lot of his experiences as well. So he's very much a presence in the book. Great. I'm afraid we're coming to the end, but thank you so much for joining me today, and congratulations on the publication of your book.
Yeah, thank you. My pleasure.